Greetings. My name is Amin Mahmood. I'm a structural engineer based in California, United States of America. In this short video, I'm going to talk about the proper use of structural steel for home or any building construction. So I'm going to share my presentation with you right now. Use of steel beams for home construction in Afghanistan. This is a picture of current use of how beams are used. These are steel beams, very closely spaced, which is very, very uneconomical. And then wood boards are placed on top of the steel beams, covered with plastic sheathing and mud. But you can see plastic is visible through here. And then on top of it, they just put mud, which is called Cargill, which is very, very dangerous because the beams are not secured in place. And just weight is added to it without taking full advantage of the steel capacity. So this is incorrect way of using it. This is another picture. This is in Kabul. The previous picture, this was in Paktika. This is in Kabul. This wood beams placed on steel wood boards, placed on steel beams, covered with plastic sheathing and mud. This picture in Kabul, very dangerous. You can see they're wiring here, and there's mud through it. The steel has already corroded. The mud is broken, and this is very dangerous. It's imminent to collapse. This is a picture from the Paktika earthquake in 2022 that I visited there, and I took this picture myself. These beams cause heavy loss of life because they were not used properly. Fortunately or unfortunate to say, fortunately, Afghanistan now produces good quality steel beams and steel rebars. That is the good part. The bad part is that nobody knows how to use them, how to use the beams. The rebars, they know some degree of the information is knowledge is available there, but steel beams are not taught at the Afghan universities. They are produced, but nobody knows how to use it. And these are the examples. That's the way they use it. Steel double T's, please. This is better than the wood. These are T's. Steel T's are placed on top of the beam without welding it. They are not welded. And these concrete bricks are placed on top of it like pavers. And then the plastic and mud goes on top of it. This is the bottom view of that. See, these are the T's. These are the beams. These are the inverted T's. These are the blocks on top of it. And this is another picture of the same. This is in Gayan district of Paktika. This is a mosque, as you can see from the two speakers. And these are steel T's are placed without being welded. This is another picture of the same mosque. You can see these are beams. The green line is the steel T, and these gray are concrete blocks on top of it. Concrete pavers. This is one of those big 8-inch beams of 20 centimeters deep. And these are the brick which were on top of it. These are the T's, which just, there's no sign of any welding on top of it. As a matter of fact, these wood beams didn't fail. They just fell down, but these failed. Steel beams failed a little badly. This is a closer picture of the previous one. Double T's, the T is dislodged. Local buckling of the beam flange. This is engineering terminology that's called buckling. You can see there's a sign of corrosion. That means this area is dipped. That means this one failed. They call it local buckling. If the beam was secured in place without being allowed to tip over, this would not have happened. This is the correct way, which is used in most developed countries, United States, Japan, Germany, China. Headed studs are welded to beams. These are called headed studs, like a bolt. They are welded to the beams and composite concrete topping on top of it. What they do, they have a machine. They weld this one and punches through the sheet metal. It burns this one and welds to this the orange color beam. And then they put some kind of a steel mesh and then put the concrete on top of it. This becomes very, very, very strong. So the concrete topping takes compression, relieves the beam from compression. The compression load is all taken by concrete, concrete is very good in compression. And the top flange of the beam, which was taking compression before, It's now completely relieved. And also prevents the beam from tipping over because it's tied. Without that technology available in Afghanistan, I suggest this is a preferred use of steel beams. T's welded to beams, holes for securing rebars, composite concrete topping. These T's, instead of putting it a full length like they here put it here, small pieces could be done. Small pieces and welded front and back with a hole in it. These holes all line up and then rebars go through it, reinforcing bar. And the other rebars go on top of it and put a concrete topping, which will secure the beam from tipping over, and also will take all the load. The compression load will be taken by the concrete topping. Composite topping take compression, relieves beam, the beam from compression, prevents beam from tipping over. If it doesn't tip over, the big beam will be very strong. There's a picture of a horse with a saddle tied on it, safe to okay, saddle tied to its chest, safe to ride for the rider and for the horse. You can see there's a belt under the chest of the horse. It's completely tied. And this is the same horse, the same saddle, but not tied. If you have this kind of a thing, if somebody is riding it, it's very dangerous for the rider and also for the horse. Most likely, just very quickly, the rider will fall off, the saddle will fall off. And if it's tied, this one, it's very secure. The beam, this is like a saddle tied up. These are saddles not tied up. They're not tied up. So this is the end of the presentation. We need teleeducation, vocational for like the carpenters, masons, anybody who use these things without a college degree, and also university level student, they should be taught. Practical ideas, to be creative, not think outside the box. In other words, these angles welded to it, they're not in books. That's something that we have to think about, think of our own past experience. That was the presentation for this subject. Thank you very much. Have a good day. Bye-bye.